The Wingate Test is an anaerobic test, most often performed on a cycle ergometer, that is used to measure peak anaerobic power, as well as anaerobic capacity. The test, which can also be performed on an arm crank ergometer, consists of a set time pedaling at maximum speed against a constant force. The prototype test based on the Cumming unregistered trademark S test was introduced in 1974, at the Wingate Institute and has undergone modifications as time has progressed. The Wingate test has also been used as a basis to design newer tests in the same vein, and others which utilize running as the mode of exercise instead of cycling. Sprint interval testing such as is similar to the construction of the Wingate test has been shown to increase both aerobic and anaerobic performance. The Wingate test was developed at the Wingate Institute in Israel during the 1970s. Validity. In order to determine validity of a testing procedure, one must test the protocol against a gold standard, which is trusted to elicit the true values. In instances where there is a euro or a gold standard, a euro such as hydrostatic weighing and determination of body composition, this is an easy task. There is however no such standard protocol for the determination of either anaerobic capacity or power. Due to this problem, the Wingate test has instead been compared with sport performance, sport speciality, and laboratory findings. These comparisons have determined that the Wingate test is measuring what it claims to measure, and is a good indicator of these measurements. Application. The Wingate test is believed to show two things: all-out peak anaerobic power and anaerobic capacity. These two values have been reported as important factors in sports with quick, all-out efforts. Short sprinting events rely heavily upon the anaerobic energy pathways during execution, which leads to the theories that greater performance in a Wingate test can predict success in these events. This has not been proven, and the more applicable theory would be that improvements in Wingate scores could predict improvements in sprinting times. Variations. The Wingate test has undergone many variations since its inception in the 1970s. Many researchers have utilized a 30-second Wingate, while others have lengthened the duration to 60-second or even 120-second. The main purpose of this alteration is to more fully stress both the alactic and lactic anaerobic energy systems, which are the main source of energy for the first 2 minutes of exercise. Another alteration that has been made is the repetition of Wingate tests. In current literature, this test has been repeated 4, 5, or even 6 times in one testing session. Repeating the Wingate test during training sessions can increase aerobic power and capacity, as well as maximal aerobic capacity. The last common alteration is the workload during the test. The original Wingate test used a load of 0.075 kp per kg body weight of the subject. As these were young subjects, it has been suggested that higher workloads should be used for adult subjects, and several different loads have been utilized. Catch al. used workloads of 0.053, 0.067, and 0.080 kp per kg body weight, while other researchers have increased the workload even higher to 0.098 kp per kg body weight. The advantage of increasing the workload can show an increased, and therefore more representative, value for peak power in collegiate athletes. Although the workload can be altered, a standard Wingate test still utilizes the original workload. Common testing procedure. Before the subject starts the Wingate test, they typically perform a low-resistance warm-up for at least 5 minutes to help minimize the risk of injury. During the warm-up the subject generally completes 2 or 3 15-second euro or sprints euro to make sure they are used to the fast movement before the actual beginning of the test. Upon completion of the warm-up the subject should rest for 1 minute, after which the test will begin. The subject will get a 5-second countdown to the beginning of the test, during which time they will pedal as fast as they can. Upon the start of the test the workload will be dropped instantly and the subject will continue to pedal quickly for 30 seconds. If using an ergometer with an electromagnetic brake, data will generally be shown through a computer. If using a mechanical ergometer, the researcher will need to count and record the number of revolutions pedaled for every 5-second interval during the test, through which power data can be determined. Upon completion of the test the subject should pedal against a low resistance in a cool-down phase. The Wingate test can be completed on several types of bicycle ergometers, which can be controlled with either mechanical or electromagnetic brakes. If an ergometer with an electromagnetic braking system is used, it must be capable of applying a constant resistance. Relevant calculations: peak power, ideally measured within the first 5 seconds of the test, and is calculated by where T is time in seconds. On an ergometer with mechanical brakes, the force is the resistance added to the flywheel, while distance is where is the distance around the flywheel. Peak power values are given on a computer with electromagnetically braked ergometers. Power is expressed in watts. Relative peak power: this allows for comparisons between people of varying sizes and body masses, and is calculated by where BW is body weight. Anaerobic fatigue: anaerobic fatigue shows the percentage of power lost from the beginning to end of the Wingate. This is calculated by where PP is peak power and LP is lowest power. Anaerobic capacity: anaerobic capacity is the total work completed during the test duration. Where is power at any point starting at the beginning of the test to the end. Testing considerations: diurnal variations occur within the body in many forms, such as hormone levels and motor coordination, therefore it is important to consideration what effects may become apparent in Wingate testing. Recent studies have confirmed that circadian rhythms can significantly alter peak power output during a Wingate test. According to these studies, an early morning Wingate test will elicit significantly lower peak power values than a late afternoon or evening Wingate test. As in every physical exertion, there are several outside factors which can play a role in Wingate performance. Motivation is present in almost every sporting event, and some believe that it can improve performance. Cognitive motivation has not been shown to influence Wingate performance. Emotional motivation, however, has been found to improve peak power ratings. It is therefore suggested that all outside factors that involve emotion be standardized if possible in Wingate testing environments. Another outside factor which is important to consider is warm-up. According to some literature, a 15-minute intermittent warm-up improved mean power output by 7% while having no impact on peak values. These findings suggest that warm-up is an unimportant factor in peak power levels, but if mean power is the variable of interest, it is important to standardize the warm-up. Since the Wingate test stresses the anaerobic metabolic system's glucose consumption, pre-testing can be another influential factor. The anaerobic energy systems utilize glucose as the primary source of energy, and a greater quantity of glucose available could influence the power output over short intervals. Therefore, glucose consumption prior to testing should be standardized between all participants. Sampling rate can severely impact the values obtained for peak and average power output. Sampling rates consistent with a standard mechanical ergometer test show significantly lower peak and average power values than a test which has computer data feeds with much higher sampling rates. Furthermore, tests utilizing low sampling rates,